Hello DE students, this lesson is on data sheets. So data sheets are super important documents when we are looking at digital components. They give us all the information we need. This lesson is going to break down the different parts of the data sheet and where we get certain information from, as well as how to find data sheets because they are all on, you guessed it, the internet. So let's get started. This lesson is titled 1.16b and focuses on data sheets. In this activity, you'll be introduced to manufacturer data sheets for electronic components. So first, let's take a look at our subfamilies of our logic devices. So far in class, you've worked with logic gates, individual gates that are added into your schematic. Now, you also looked at a flip-flop and a 555 timer. They fall under the LS, as do what we refer to as IC chips, which are groups of logic gates put together. So we're going to be taking a closer look at those very soon. And you will notice that the LS actually stands for the low power Schottky family. And that number that goes with all of these is 74LS04. So the change is always over here at the end. Every component has a different ID number. And these are the ones that we are going to actually work with the most, are the low power Schottky family. So let's talk about how we number our electronic components. So the first thing that we look at is actually our manufacturers. So there are two main electronic component manufacturers. We have Fairchild Semiconductor, which is labeled DM, or SN, which is Texas Instruments. Most of the components that we would use in class are actually from Texas Instruments. The next item that we have in our number is the series number. So most of what we work with is in the 74 series. And then the logic subfamily, like I said, is the low power Schottky, so that's the LS. And then we have what we refer to as the logic function. So every function has a different number. So over here, you'll see that a 04 would be an inverter, a 08 is an AND gate. So that number right there actually tells us what gates are inside of our object or what function it performs. And then the last thing is the package style. So that is just how it attaches to a circuit board or a breadboard. So all of this information gets contained in a manufacturer data sheet, and a manufacturer data sheet for a logic gate contains a lot of information. It gives us a general description. It tells us how the pins are set up so we can wire them properly. It gives us a function table or a truth table so we know how the gates operate, as well as operating conditions, so how it actually would function inside of the circuit, electrical characteristics, switching characteristics, as well as physical dimensions, so the overall size of our component. So this is what a data sheet looks like. This is from Fairchild Semiconductor, and it is for an DM74LS08. So this is actually an AND gate. And what we're looking at is this is an IC chip. So this is actually 4 AND gates built into one chip. These are super, super useful when we're breadboarding because this is how we control where electrical components go within our circuit. So the first thing is a general description of that component, and over here you'll see that area enlarged, and this says that this device contains 4 independent gates, each of which performs the logic of an AND function. The next thing we have is our connection diagram. So these chips are actually physically small little tiny black boxes, and they have a total of 14 pins on the exterior. These pin numbers tell us how we can connect things. So as you can see, number 1 and 2, so pin 1 and pin 2, are inputs, and the output is pin 3. So if we had a high signal in 1 and a high signal in 2, we would have a high signal in 3. So that's how those function. We also have pin 7 as ground and pin 14 as the VCC or our connection to power. Each of these components has to be connected to power individually. So next we have our function table. This is telling us that this is again our truth table. So we have a low logic level and a high logic level. Remember when we say a high logic level, that means that we have our full power, and a low logic level means very little to no power. So what this is saying here is that this is what makes this statement true. So y is equal to a and b, and that means that a and b together are how we get the output of y. You'll notice that this is for an AND gate. So if a is low and b is low, that means y is low. And the same holds true until a and b are both high signals, and then we get that high signal as our output in y. So also included in the truth table are recommended operating conditions. So this tells us what the minimum amount of voltage is, our max amount of voltage, anything that the high level and the low level should be, if that's necessary, if there's a temperature condition that it has to meet, all of those things. And then we also have our electrical characteristics. So these are the characteristics of what is happening inside of this component. And then these are all of the things that if we were actually working on soldering these into a circuit board, that we would have to keep in mind as we were setting up that circuit board. And then we have switching characteristics. This is really important when we look at things like flip-flops where they either trigger low or trigger high. This tells us how that actually functions. So here what this is telling us is that we have for our high to low level, any delay in time for the switching that we might have. And then we also have the physical dimension. So this is what the exterior of an IC chip looks like. You guys are going to see these in Tinkercad and then hopefully in real life very soon. But what we're looking at here is pin 1 is always marked with this little circle and the indent. Again, pin 1, 2, and 3 are all connected. 4, 5, and 6 are connected. 7 goes to ground. 8, 9, 10 are connected, 11, 12, and 13 are connected, and then 14 is our power. So you'll notice that this, if you know how to read a technical drawing, which you all should, this gives us the physical size of the different views of the chip. So it also gives us a side view and a top view. So this would be a multi-view drawing, solid throwback to IED for you. And that is all of the information that is included inside of a datasheet. Hello, DE students. This lesson is on datasheets. So datasheets are super important documents when we are looking at digital components. They give us all the information we need. This lesson is going to break down the different parts of the datasheet and where we get certain information from, as well as how to find datasheets because they are all on, you guessed it, the internet. So let's get started.